Okay. So for the very first question, what is the gravitational force? Gravitational force is the force of attraction between two masses, right? So you should always write that. And then binary star system, right. So this goes here, no, here, here. Acha. Fine. Observe from Earth, the angular separation of the center of this one is this, and the distance of binary star from Earth is this. Show that the separation center is this. Okay. Now, in this, what it means is that let's suppose if this is the star, this is another star, right? This is Earth, suppose. So it's saying that the distance of binary star system from Earth. So let's make it from the center. So this distance is 1.5 times 10 raised to 17, and the angular distance from the angular separation, and this whole angle is 1 point. Okay. So to do that, we have to use arc length. Okay. So S equals to R theta. So the radius, I mean, this would remain the same, right? All the time. So the radius has to be 1.5 times 10 raised to 17. And the theta has to be 1.2 times 10 raised to -5. So I think it should be the same, but can you guys confirm if you've done it? Okay. I think it should be the same. Who hasn't done the paper? Shayan? Haven't done it? 1.8. Yeah, that's fine. Okay, then star, it says that they rotate with same angular speed about point p. The p is the distance x from the center of S1, and period of rotation is 42,442. Okay, not bad. Calculate the angular velocity. So omega 2 pi by t. This will be 44.2 times 10, times 365, 24 hours, 60 minutes and 60 seconds. So this is
4.5 times 10 to the power -9.
4.5 times 10 raised to -9. Okay, that's cool. Then it says, by considering the forces on two stars, show that the ratio of masses of star given by this. That's fine. Now, you know, the forces are centripetal force, which is mr omega square, and it is equal to gmm over r square, right? So what are we going to do? We're going to say m1 and m1 m2, like this, right? So m1 and m1 cancel out. And this is basically, well, okay, let me write it down. Yes, I mean. To prove it now, we just need to. So force on S1 would be M1. S1 was basically X, right? X and mr omega squared, like this, right? And the force on S1 is also equal to G mass of 2 times mass of 1, and the distance between both of them is D, as I can see here, right? So now you can actually D square actually. So you can put it equal. So, well, M1 and M1 cancel out. So you get M2 D square equals to X omega square, just like this. Okay. You could do that. And then what you can do is you can replace omega somehow. To replace omega, I would find a force on S2, which is equal to M2 D minus X and omega square. Right. So no. It would still, I could put omega, it will be longer this way. Why don't we just put them together? That would be helpful instead of going into this part. Yeah, this is all wrong. I mean, it's not wrong, but it's easier this way that I just found. Because omega square will cancel out, and M1 over M2 will be equal to D minus X over X. Yay! That's simple. Okay, use your answer to determine mass M1. The mass of S1 is given by equation, where G is the constant and the ratio is found to be 1.5. The ratio in 2 found to be 1.5. Well, if M1 over M2 is equal to 1.5, which means D minus X over X is also 1.5. Acha, okay. Could do that, I think. This means that for some reason, right? Somehow I want to replace, I want to just get out of this. चलें वो हम अपनी तरफ से कर लेते हैं. It's not a big deal at all. We have omega, we have G, and we can use this to find 1 point. So fine. 1.5x equals to D minus X. X will go there. So it will be 2.5x equals to D, right? ठीक है, अब हो जाएगा. So this means that I could actually put it back inside. So 6.67 times 10 raised to minus 11. And this is M1. This is 2.5x whole square. And 2.5x minus x omega square. Omega की value क्या निकाल दी थी? 4.9 something, right?
4.5 times
4.5 times
10 is to minus 9.
Like this, right? अच्छा, अभी भी तो हमारा आंसर तो नहीं आ रहा है इससे. ये तो गलत बात है ना. ये तो बहुत गलत बात है. हमारा आंसर आना चाहिए था इसके ऊपर. Because जो D है, हमें x तो रिप्लेस होना चाहिए इसके अंदर. ये तो हुआ नहीं.
D पता है ना हमें.
D हमें पता है क्या है D?
हाँ सर, D हमने निकाला था. ये रहा.
Oh yes, ये तो हमें पता है. एमी हम परेशान हो रहे हैं. 1.8 into 10 is to. अब तो हो गया, सारा क्वेश्चन हो गया हमारे पास. हम x में एमी जा रहे हैं, हम तो D में जाना चाहिए था. सॉरी. अच्छा, इसको थोड़ा सा हमें चेंज करना पड़ेगा. इसको हम लिख लेते हैं x equals to D over 0.25. 1 upon 2.5 is what?
0.4.
Okay, 0.4. So ये आ गया 0.40. अब हमारे लिए आसानी है. This is better. D हमारे पास था 1.2 times 10 raised to power 8. I think ये इसने बताया मुझे. नहीं, 1.8 times 10 raised to power 12. Okay, so this is square and this is 1.8 times 10 raised to 12. Minus 1.8 times 10 raised to 12 times 0.4. And the answer will be? Yes, Malika. Anybody else who has taken it out? So complex.
Sir,
Right?
1.1 times 10 power 30.
Yes.
Okay, that's cool. अब तो हो जाएगा. मैं समझा D नहीं given है. मैं बड़ा परेशान. मैंने कहा यार कैसे दो variables आ गए? Why? अच्छा, what is meant by internal energy of the system? Internal energy of the system is the sum of, for 2 marks, we always write, sum of kinetic and potential energy of randomly moving atoms. So this is 1, this is 2. Okay, for 2 marks. By reference to intermolecular forces, explain why. The change in internal energy of an ideal gas is equal to change in total kinetic. Okay, that's pretty easy. In ideal gases, there are no intermolecular forces. How many marks is this? 2. Okay. Hence, potential energy equals to 0. So, internal energy, which is equal to kinetic plus potential, will be equal to only kinetic. That's what you got, right? But in words. All right. Now, state and explain change of internal energy of solid ball as it falls under gravity in vacuum. So there's a solid ball which is falling. Internal energy of, so potential energy तो इसकी change नहीं हो रही है. It just changes its gravitational potential energy, which is different, right? So neither potential energy nor kinetic energy change. So that should be 2 marks. And for the next mark, so internal energy must be same or should stay same.
फिर मैंने इसमें thermal energy और no volume change ये लिखा था कि no thermal energy is transferred and there is no change in volume.
So that could be true.
सही.
That could be true. There's no change happening really. अच्छा, उसके बाद ये कहता है एम्पलीट्यूड बताओ.
Work done लिख सकते हैं?
Sorry?
No work done.
No work done. Okay, you could say that.
Okay.
No work done, and there is nothing, work done against resistance. Yes, that could also be correct. Okay. All right. Lisa, ये आपका कुछ सवाल?
I'm sorry, sir.
अच्छा, Lisa ही है. I thought मैंने कहा इतने दिन बाद मनाहिल ने हमसे कुछ पूछ लिया. I was like shocked. Okay. Then 9.8 is the movement, right? Total. So the amplitude would be half of it, I believe, right? Should be half. 9.8 का half क्या होता है? 4.5, 4.9. Okay. Then its frequency. So you have 27,000 oscillations in 1 minute. So 27,000 per second. 2,700 per second. कितने होंगे? 60 से divide करेंगे. So
45.
oscillations. 25. 25 hertz. 45.
45.
Okay, Lisa. 45. 45 hertz. Okay, maximum. So for this one, maximum speed, we have to use W. V equals to maximum speed. What is this? Let me think about it. Should we be using omega and omega square x naught for this maximum speed?
Sir, safe omega x not with use कर सकते हैं.
Omega x not be used as a pen like this. But why how x naught is 4.5, right? 4.9. Omega में मान लो. Omega is 2 pi f and x naught is 4.9 times 10 raised to power minus 2. We could do that, right? कितना आ गया?
14.
13.9.
14 meters per second. All right, that would be the one. That's pretty simple, right? Speed when the top is this. Okay, that's simple. V equals to omega under root x naught square minus x square plus minus. So omega आ गया 2 pi 45 under root x naught आपके पास आ गया 4.9 times 10 raised to power minus 2 whole square minus 2.3 times 10 raised to minus 2 square. So the answer is, by the way, this formula is
11.7.
11.7. This
Oh,
formula
sorry,
is
मैंने derive करा था.
नहीं करने की जरूरत. This is given in the data sheet. Okay.
Wow, sir.
Okay. The acceleration of piston varies. Determine the resultant force. Okay. Determine the resultant force piston gives rise to maximum acceleration. Acha, resultant force we can use as how would we use it actually? F equals to mr omega square. We have the mass, right? उसके बाद maximum acceleration के लिए, right? mx naught mr omega square. Okay, so mass should be given. What is that? 640 times 10 raised to minus 3. X naught is 4.9 times 10 raised to minus 2. And omega is 2 pi 45 whole square. Can you find the answer, please?
It's 2.5 times 10 power 3. 2,500.
Okay. So that would be the answer, right? Any questions, please? Okay, cool. Now, by reference to ultrasound, explain what is meant by specific acoustic impedance. It is the product of density and speed of sound in the medium. Usually 1 mark, 2 marks. Okay, the ultrasound wave is incident normally, and the media have specific acoustic. Show that the ratio intensity reflected intensity on the boundaries relative to the magnitudes. It's very close. It's very simple. If Z1 minus Z2 is equal to 0, right? So this means that it is going to be transmitting more transmission. All right. Or you could write vice versa, right? Whatever. So this means that the ratio I of reflected over I of incident will be greater if Z1 minus Z2 is nearly 1. Do you guys understand what I'm saying? So that's what it means. Okay, what is meant by attenuation? Attenuation is not in your course anymore. So we're going to pass it. But for, just, you should know, loss of power. I don't think so.
अगर loss of intensity लिख दे तो वो भी acceptable होगा.
That's fine. That's fine. Power is related to intensity.
Sir, what about amplitude? Oh, yeah.
That's also correct. All of these are related to each other. A parallel beam, I'm not very sure about whether they're going to give you this or not. So this is ambiguous, right? And you should write it down still. Okay. The parallel beam of this is intensity I reduced to this passing through thickness of this. I equals to I naught E minus mu x. So I is 0.35 I naught. This is just I naught minus mu, and this is 0.046. This cancels out. ln 0.35 equals to minus. So when you do this, what is you?
22.
23?
Yes.
That's cool. Okay.
Am I the only one who got minus 22.8?
Because you forgot the minus sign is here. That's fine. That's why.
No,
Lisa.
I did
मैं
write the minus.
अभी मैं आपको दिखाता हूँ. When you take ln of 0.35, it is a negative value. So minus and minus cancel out jata Lisa. When you divide it by minus 0.046, बाद में आपने मानना नहीं. देख लें.
So मैंने भी तो यही कहा है.
जी आप माइनस नहीं लगाया आपने बस. तो आपने कहा नहीं. No. Said no.
नहीं, I said it's 22.8. I never
With
said it's negative.
the minus sign is there. Okay.
I never said that.
Okay. State one similarity. All right. Maybe I'm wrong. So one similarity, one difference between the field's forces isolated. Similarity of forces are that they're always radial. Radial fields, that's always. And difference is that between point and charge. You know what is the difference? The difference is that field in gravitation is always pointed towards the mass. It's never away. That's why. So strange. Okay, then it is a sphere. Determine the expression that includes RQ electric field strength at P. So this should be actually R. So it makes up 3R. So KQ over R. So KQ over 3R. Shouldn't it be the answer?
Or wouldn't it be 4 pi 3r squared?
4 pi 3R
And
squared.
then you square the 3 also.
Yeah, sorry, my bad. You're right. You're right. I forgot about it. So it should be 9R then, right?
Wouldn't it be 36?
Why? If you
36
remove,
pi.
Yeah.
Oh, you're removing that. Okay.
so if you remove K, then it will be 4 pi 1/4 pi epsilon and
R square.
times r square.
Nine.
Then it is 6, है ना? वैसे हमें लिखना है Nahil is right. We should be writing it like this. So 36 pi E naught r square. Wow. Itna easy, itna difficult. You see, looks scary to me. All right. Okay. Then you have midway charge. Explain why the magnitude of electric field strength at P given by the sum of magnitudes of electric field strength due to each square. Okay. First of all, I would like to tell you that charge V is minus Q. The magnitude of electric field strength at P is given by the sum of magnitudes of electric field strengths due to each. This would mean actually that they are oppositely charged. Yeah, they are oppositely charged. So electric field is like this and this. Okay. So basically, spheres have attractive forces, right? So fields are in same direction. That should be the answer. The electric field strength at P due to charge matrix is not in practice equal to E, where E is the electric field strength determined by B. At P it is not 2E, it's a okay. Well, in reality, I'll tell you something. Okay. When charges are brought closer, their centers are disturbed, no matter which is this. Hence, they ideally, sorry, not ideally, practically do not behave as point charges. Do you guys understand this?
तो ये जरा फिर से explain कर दे.
Okay. Okay, I'll tell you. So let's suppose there is a charge here, right? There's another charge. Alone, they would have like this distribution. What do you say? Right? If you bring them closer, their distribution goes like this.
Oh, same.
So now their centers have been changed. Okay, now there are no more point charges. That's fine. Okay, this is not there anymore. Let's go forward. This is not there. Over the weekend, I told you I will give you a worksheet for the questions. Fine. Okay, Tesla. This is something you guys need to understand, that you can use anything, but usually F is equal to BIL he uses. So for B, what is Tesla? That all of these should be perpendicular to each other. So you say magnetic field is perpendicular to current, and then you say 1 Tesla is equivalent to 1 Newton per ampere and per meter. Like this. Okay, so you just need to write the units. Okay, now this is sort of a question. There is a weight, there is this. Okay, fine, not a big deal. It says explain why section QL of the wire gives rise to movement about P. QL. So here the current will go from like the current is going like this, right? From Q to L. Let me change the color. So this is our current and this is the magnetic field. So the force will be downwards. Yeah. Why QL? So we say that QL is perpendicular to the magnetic field, right? First of all, that's true. And so there is a force acting onto this side. Okay. Then force is downwards. That's what we did. And give rise to moment about the pivot. Section wire gives the moment. Where is the pivot, by the way? Is there a pivot this way? Okay, yes, it will be pulled and this is the pivot. Okay, fine. And there is a perpendicular distance towards perpendicular distance between force and pivot. So that's what you should write. Okay. Now it says section PQLM do not affect the equilibrium of the wire because the current is going like this. This is going. So this is the field. Current is down, field is this. So this applies force outward. This applies force this way. Okay. So we say forces are not perpendicular to pivot, first of all. They are equal and opposite. So you could write it like this. Pretty simple. And then QL is a section of this. The perpendicular distance QL is this. Okay. So it's saying, all right, whatever. When the current is this, W is moved to a distance of 2.7 along the wire to restore equilibrium. So W is moved this along the masses. Show that the change in momentum about this is this. Okay. First of all, we find the force. Force is BIL, as you can see. B is, my friends, what is B? That is not fair. They haven't given us B, but why? Okay, we don't need it. We can find the moment. If
We
this
have
was,
F.
yeah, we have F. Where we have F? We
नहीं
don't
नहीं
have
sir,
F.
sorry, मैं उसके next part की बात
I'll
कर रहा
tell you why. This is the pivot. This is the whole thing, right? So this is where the force is, and there is a pin here that I can see, right? अब वो ये कहता है कि change in moment. It was moved backwards with a distance of 2.6. So this is the change in length it moved, right? And uska weight जो है ना, the mass of W is this. So first of all, we'll use moment. 1.3 times 10 raised to minus 4 times 9.81. This will give us the force, and the change in length is 2.6 times 10 raised to minus 2. What is this? Very clever people, right?
Sir,
Go on.
13.3 times 10 is power negative 5.
Yeah, negative 12.
Negative 5.
5 ही आ रहा है.
ठीक है. उसके बाद कहते हैं use your information to determine the magnetic flux. अब बड़ा आसान हो गया. अब we can find the force. कैसे force? Because force F into D equals to 3, क्योंकि same है ना, equilibrium में होना चाहिए. This force we need, and the distance to pivot is 5.6 times 10 raised to minus 2. So what is the force then? Who's gonna get me the force?
मैंने हर चीज डायरेक्टली करी थी.
Okay, go on.
So 5.6 times 10 power minus 4. 5.9 times 10 power minus 4.
5.9 times 10 raised to minus
4.
4. Okay, then what do you do? F equals to BIL. So 5.9 times 10 raised to minus 4. Current इसमें था 1.2. And what was the, I don't
0.85 over 100.
know, 0.85, yes. So the answer was
5.8 times 10 power minus 2.
yay. Lisa, did you get it correct? Lisa, चुप होती तो इसका मतलब था कोई मसला हो गया. Question सही नहीं.
No, sir, I have calculation issues,
Mistake.
trust issues.
Yes. No, we have trust issues on your calculations.
वैसे सर मानना पड़ेगा, आप कोई मौका नहीं जाने देते मेरा मजाक उड़ाने.
Okay, now show for the time t0 and time t20 2.0 the EMF of the force induced is this. So now basically what you do, you can take the gradient, you know this, and there's I don't know, the three. First of all, we got to find the change. Okay, so निकाल सकते हैं हम, it's not the big deal. अब EMF जो होता है ना, it's basically change in flux times n upon change in time. Now flux is basically BAN times T over okay, BAN over T. Okay, so first of all we'll find the change in B over time, right? So B was right here. I think it was, ये क्या होता है?
45.
45. Okay, 45. 45 times 10 raised to minus 3. Area, I don't know. Did they give area? Diameter given. 3.6 centimeter. So pi by 4 times 3.6 times 10 raised to minus 2 whole square. And then number of turns were 350. 350, you know? 350, okay. 350 divided by the time was 0.2. 0.2. That should be the change. हाँ, यही change आना चाहिए. Okay, what is the answer then?
0.08.
क्या बात है? Okay. Then on axis show the variation of induced TMF for the first time. This is positive gradient. So from 0 to 2, it will show you 0 to, it will show you negative 0.08. I think it should be somewhere here. And then for the next, it will be 0, 2 to 4. And then here, it will be 4 to 8. 4 to 8. I don't know. ये कैसा होगा, but it will be less than this. It will
Sir,
be
half
small.
ही आ रहा है. 0.04 आ रहा है.
उसने कहा था निकालो. अच्छा उसने कहा हुआ है. So you should actually find it. Yes. तो ये half आ जाएगा, फिर इधर आ जाएगा.
Oh, sir, ये मैंने गलती कर दी. Opposite direction नहीं करा.
Opposite direction on J because this is negative. Okay, done. Right? All right. Now, going to the next one. It says aluminum disc is supported horizontally by held stationary magnets rotated about. Use law of electromagnetic induction to explain why there is a torque acting on aluminum. Okay, this is pretty simple, right? What you do, you should understand that the magnetic field cuts the aluminum disc. ठीक है? as it is constantly rotated. So there is a change in flux linkage per unit time, which induces EMF. And finally, EMF causes eddy currents, which opposes the change. वैसे लिख सकते हो लेंस लॉ के मुताबिक, ठीक है, change, hence applies a force on the disk. Is it clear? All right, now 10. For the light that passed through the gas at continuous spectrum seen, use the concept discrete electron energy level to explain the existence of these darker lines. Okay. So first of all, white light goes through cool gas. It excites it, right? Excite means that photons are absorbed by an electron, right? So we went right. ये कितने mark है? 4. Okay. Photons absorbed by electrons, right? Electrons jump to higher energy level. Okay. Energy of photon must correspond to difference of energy between levels. And fourth, right, should be when electrons de-excite, they release photons in all directions. Is it clear? That should be written actually. So why there has to be de-excite की spelling होनी नहीं चाहिए वैसे. De-excite की excite. Okay. Now this is not there anymore. So chill.
एक सेकंड, वो क्या कहते हैं, इसमें डी एक्साइटिंग के बारे में लिखेंगे?
लिख सकते हो. मैंने 4 मार्क पूरे किए हैं एक्चुअली. It was no need, but I thought maybe.
So, लेकिन अगर वो रिलीज करेगा फोटोन तो वो वाला कलर फिर नजर भी आएगा.
लेकिन वो किसी भी जगह रिलीज कर सकता है ना, जरूरी थोड़ी ऐसी लाइन.
हाँ सही, ठीक है सर.
इसलिए मैं लिख दिया the photon in all directions.
सही है सर, समझ गया.
All right, then band theory is out, and this is okay. Calculate for 1 gamma ray photon the photon joule energy. Oh, but the point is that do we even know the wavelength of gamma, or is he trying to enforce that? Well, it doesn't matter, because it says a positron interacts with an electron. The electron positron may be considered to be rest. Outcome if interaction becomes a gamma ray photon, each having 2 gamma ray. Fine, we could do that totally. So we have 2 mass of electrons getting annihilated. Annihilated means E is equal to mc square. So the mass would be 2 times 9.11 times 10 raised to the power minus 31 multiplied by 3.0 times 10 raised to 8. Can you check what is the energy of 2? Yes.
Um, 1.6 10 to raise power minus 13.
Minus 13 joules. Okay. This is for 2 photons, right? So we got to divide by 2. So it will be 0.8 times 10 raised to minus 13. है ना? है ना? That should be 0.8 should be 8.
Wait, sir, why did you times it by 2 and divide it by 2?
Because they were like one positron and one electron. They combined to give 2 gamma rays. Well, you're right. I could have just taken, divided by 2 already. That's the same thing.
सर आपने speed of light का square क्यों नहीं किया?
हाँ, मैंने स्क्वायर ही नहीं किया. फिर ये गलत आंसर हो गया ना. फिर आप चेक करें इसको.
जी.
इसको
नहीं मैंने
सर
किया है
आंसर
अच्छा
8.2 times 10 to the power negative 14.
8 पॉइंट. ठीक है. तो इसका मतलब लीजा ने पहले से कर लिया था. हाउ स्मार्ट लीजा इज. ओके. नाउ
तो
मोमेंटम.
मेरा भी टाइम आएगा.
मैं तो आपको तारीफ किया लीजा भी. ओके. एनर्जी इज momentum into speed of light. If you don't know. Okay. So energy is given already. And we can divide by C. And what do you get? Momentum.
So 2.7 times 10 to the power negative 22.
Negative 42.
22.
22. Okay. State and explain the direction relative to each other in way the gamma. Opposite. Exact opposite. Opposite direction. Why? Because when these annihilate, right? This pair annihilates. This is also in the PET. Okay, so they should go in opposite direction. Why? Because so that law of conservation of momentum is applied. That's fine. Okay. Now, going to 12. Random decay means that you cannot predict when the next decay will happen. Cannot predict when or which nucleus will decay next. Okay, spontaneous. Cannot be affected by external factors like environmental effects. Okay, then you have radioactive isotope of half-life. Pure sample of isotope is this. Determine the activity after 2 hours. Okay, I think we could do this. We have the half-life. And we can find lambda by doing 0.693 divided by 1.4. What would that be? Sorry?
Sir, 0.495.
495 Rs minus 1, right? Then you use A equals to A naught E minus lambda T. A naught will be 3.6 times 10 raised to 5 times E minus 0.495 times 2 Rs. So the activity will be
1.3 times 10 raised to the power 5.
yay. Okay. Now this one. Okay. The initial activity of isotope X is 3.6.
Sir,
Use that.
don't we have to convert the hours into seconds?
No, because our this time is ours. This is also ours.
Okay.
Then it says initial activity is this. Use information sketch on axis the variation of time t pure. Okay, so it was 3. ये तो पहले से sketch नहीं हुआ हुआ. Isn't it 3.6? What do we have to do? Okay, never mind. So exact इसका half क्या होगा? 3.6 का half क्या होता है? 18, 1.8.
Yeah.
1.8 pe its half-life is how much half-life is this? 1.4. Half-life is 1.4 hours. So 1.4 will be, this is 1.5, this is 1.4. So you mark a point right here first. And then the next half-life will be 1.8 divided by 2. What is that? 0.9.
Yes, sir.
And 1.4 addition इसके बाद 1.4 कितने पे आएगा? Around 1.4 plus 1.4 is 2.8 here. Okay. और उसके बाद मेरा ख्याल है 2 काफी नहीं 3 कर लेते हैं. 0.45. 0.45 it will be right here. Okay, and 2.8 plus 1.4 is 3.2 and 4.2. 4.2 is here. Okay, I think it's enough. Now we should make a nice and smooth curve like this. It should be like this. Okay. All right. Now it says that suggest an explanation for any difference between actual activity of sample and the curve you've drawn in activity isotope. Well, why is there a difference? It is this is actual, this is ours. Because it's producing more radiation, could be because of maybe the product that it's creating could be, you know, a radioactive product. Uski bhi to phir hona shuru ho jayegi na. So we could say that decay of X must have produced another unstable nucleus. So its radioactivity is also added. By the way, radioactivity is activity. Is it clear? And that's it, folks. Oh, so tired. All right. So I guess if you have any questions, please let me know. Anything you would like to know, ask.
Sir, I don't get 8C part I.
8C.
C.
All Let me just stop the recording for now.